Hello everyone. Now let's look at the second example for logarithmic differentiation. The first example we just looked at, it could be solved by using the quotient rule combined with product rule and the chain rule. So even if you don't know logarithmic differentiation, you can still find the derivative. It's just going to be a really long answer. However, now for this second problem, we have this function 2x times x to the fourth power plus 1, then to the power of tangent x. For this function, we do not have any derivative rules that can help us to find the derivative directly now. This tangent x is on the power of 2x to the fourth plus 1. We cannot use the power rule for this because power rule says n has to be a number. It could be any real number, but it has to be a constant number. Then power rule would work. Also, we cannot use any of those formulas for some base number to the power of x because our base here is 2x to the fourth plus 1. It's also not just a constant number. We have a function of x to a function of x on the power. For this types of function, the only way to find its derivative is to use this logarithmic differentiation now. So let me show you how to do this using the same method that you just saw. First of all, let me erase these formulas here. We don't need to know anymore, right? You just need to know we are not going to use those formulas. So there are the basic 4 steps for logarithmic differentiation that I still wrote down for you. Now the first step is to take ln on both sides, right? Because we need that log. And before I do that, actually I'm going to rewrite my function first because I have f of x now equals to this whole thing, and it's easier if we just deal with y. So I'm going to write it as y first, and then we do our basic steps again. First, we take ln on both sides. This basically just means we put ln on the left of each expression. Now, both of them are logarithmic differentiation, logarithmic expressions, so we can simplify the expressions. We want to simplify this right-hand side because this whole expression is something we do not know how to take its derivative. However, now we can use laws of logarithmic that says when we have a power in the logarithmic expression, the power can go outside, right? So instead of using this expression, I can also rewrite it as tangent x times natural log of 2x to the fourth plus 1. So now this tangent x, instead of being on the power, it's being multiplied with our expression now. And this would make it easier to take the derivative. Now, this is already the simplest form, right? Because we cannot split up a sum inside the logarithm. So there's nothing else we can do. We're going to move to the third step now directly. Differentiate both sides. We're going to take the derivative of both expressions. Natural log of y again, according to chain rule, its derivative is 1 over y times y prime because y is a function of x. We need that dy over dx. Be careful now for this part. Tangent x times natural log of 2x to the fourth plus 1. This is actually a product. So when you do the derivative of this, don't forget to use the product rule. We need the f prime times g plus f times g prime. Right? If you don't have these 4, then your answer would be wrong. So let's look at this. Tangent x, its derivative we have learned by formula is secant square x. And my g function, that's the natural log function, I'm just going to copy it down. And then I copy down my tangent x function, and the derivative for this natural log function, we use a chain rule again. Normally, we do derivative outside first, which is 1 over whatever we have, we leave inside alone, times the derivative inside. The derivative of 2x to the fourth plus 1 would be 8x to the third plus 0 by power rule. So that's my f prime times g plus f times g prime, right? Now we have our derivative. The next step is to multiply y on both sides, because again we're looking for y prime, the derivative function. So I'm going to write this right here to give us more room. Multiply y on both sides. My y prime would be equal to this whole thing, secant square x times natural log of 2x to the fourth plus 1, then plus tangent x times, I'm going to combine this fraction. On the bottom, it's 2x to the fourth plus 1. This 8x to the third times 1 goes on the numerator, right? And then this whole expression needs to be multiplied by y. That's my y prime. And don't forget the last step, we're not done yet, because our final answer should just be in terms of x. There shouldn't be a y in there anymore. So I'm going to replace this y by its overall expression, which is our function right here. So the final answer for y prime, let me copy down this whole thing, it's still secant square x, natural log 2x to the fourth plus 1, this doesn't change at all, plus tangent x times 8x to the third over 2x to the fourth plus 1, and then multiply y, which is 2x to the fourth plus 1, then to the power of tangent x. That's our answer for this problem.